wasn't always like this. We weren't always known for engineering. We didn't have a medical school, let alone two. And there were no PhD programs, Fulbright scholars, or thriving college town. It's easy to take it all for granted because a lot of us have never known it any other way. But just a few years ago, this was a very different institution. A well-regarded local state college that served the public without fanfare, ready to stay the course. Until one gift, a $100 million transformational gift, changed everything and set Glassboro State on the path to become Rowan University. And since then, we started one of the top 25 undergraduate engineering programs in the nation, fostered entrepreneurial spirits in our business programs, cultivated ambition, excellence, and broader horizons throughout the curricula, and responded to the national need for 21st century healthcare with innovative health sciences and medical education. In our colleges, schools, centers, and institutes, we're conducting world-class research that's meeting society's needs and solving the problems of business and industry. We're the fourth fastest growing research institution in the nation, a top 100 national public research university dedicated to excellent undergraduate education. We're providing more scholarships, increasing access to college education, and reducing the financial burden of earning a valuable 4-year degree. We're nationally ranked and routinely earn national notice for students and faculty doing extraordinary things. We're driving the economy of the region and increasing what New Jersey can do to help its citizens be healthier, more productive, and secure. Transformation is not just the story of Rowan University, it's the promise offered to everyone who walks through our doors. Students find themselves and a foundation for their future. Researchers devote themselves to discovery and understanding. Innovators, scholars, entrepreneurs, everyone with curiosity and commitment to know more and do more, they all transform our world. So when it seems like Rowan University is continually forging new pathways, it's because it's true. We're creating new ways to learn, explore, and build. We're partnering with business and industry, educators and leaders to accomplish more together. We're encouraging people to imagine, equipping them to pursue and achieve. Being transformed is more than Rowan's story. It's the future we share with New Jersey and our region. Here's to decades more discovery, growth, and transformation at Rowan University.
Hello, and welcome to all of our prospective students and their families. I'm Dr. Stephanie Farrell, Interim Dean of the Henry M. Rowan College of Engineering, and I want to thank you for attending today's virtual open house. We have an exciting program planned for you today that will include a virtual tour of our facilities, a live presentation by our department heads, demonstrations by our students, and a live question and answer session. If you have questions, please type them in the comment section and we will answer them toward the end of the program. Rowan Engineering has student-centered, hands-on, project-based programs. Lab-based courses are integrated into most of our curriculum and our unique engineering clinic course sequence. Here, students have the opportunity to work collaboratively with faculty and industry professionals, along with their fellow students, to solve real-world problems. And you'll get to be part of groundbreaking discoveries. Working on these projects often leads to summer internships, presentations at national conferences, and even publishing opportunities. At Rowan, you'll be part of an undergraduate experience that has been recognized nationally. Our outstanding students and faculty have catapulted us to a U.S. News and World Report ranking of number 17 in the nation for undergraduate engineering education. And importantly, our program is one of the most affordable engineering degrees you will find. Both our retention rate and our graduation rate exceed national averages by over 20%, and we routinely place more than 90% of our graduates in jobs in industry or in graduate school. Finally, being a Rowan engineer is not just about being in the classroom or the lab. We have a variety of student clubs and professional organizations which offer students a chance to get involved, build a network, and develop professional skills. This is an exciting time to be at Rowan, one of the nation's fastest growing universities, and to join the ranks of thousands of successful Rowan engineering graduates who are solving the problems of the 21st century. Welcome to Rowan Engineering.
The Henry M. Rowan College of Engineering is one of 12 colleges and schools that make up Rowan University. Proudly, U.S. News & World Report has ranked our college 17th in the nation in our peer group and has recognized our university as one of the top 100 public universities in the nation. Our program is anchored by the unique and distinctive Engineering Clinic. This signature curriculum structures an 8-semester sequence that ensures our students are exposed to real-world, industry, government agency, and private foundation-sponsored engineering challenges. Our curriculum successfully prepares students for both engineering careers and advanced graduate study. Students work in interdisciplinary teams to meet project goals and deliverables, work directly with faculty, and network with leading industry professionals. In many instances, students are able to secure internships and full-time employment offers through working in engineering clinics. The Department of Civil and Environmental Engineering is a leader in developing solutions for a world that is rapidly changing. From structures to transportation systems, resiliency, and environmental protection, our department has extensive expertise. Companies and agencies such as AECOM, American Asphalt, the Army Corps of Engineers, Atlantic City Electric, Gannett Fleming, and the Department of Transportation have sponsored our program and recruited our graduates. Our nationally ranked electrical and computer engineering program is one of few throughout the nation that meet accreditation requirements for both electrical engineering and computer engineering, giving our students a competitive advantage in the workplace. Notable clinic projects from the department are sponsored by Lockheed Martin, NASA, the FAA, and the United States Navy. As we grew in size and enrollment, we doubled the number of our full-time faculty, ensuring that the small class sizes and low student-to-faculty ratio, which has long been a hallmark of our programs, remains intact. At Rowan, you will not simply be one of hundreds of faces in a lecture hall. You will have an opportunity to work directly with faculty in small class settings conducive to student success. Biomedical engineering sits at the nexus of engineering and healthcare. Integrated with Rowan's 2 medical schools, our program is one of the fastest growing in the nation. Rowan students lead projects funded by NSF, NIH, and major biotechnology companies. Students have a strong record of placement in top graduate schools and careers with Merck, Stryker, Johnson & Johnson, Bristol-Myers Squibb, Medtronic, and others. Our college has recently seen unprecedented levels of growth, including bringing online a full state-of-the-art academic building, Engineering Hall, a full-scale renovation of our original home, Rowan Hall, ensuring all of our academic departments and students are able to benefit from modern, dedicated teaching and research spaces. The college's chemical engineering department has extensive expertise and a learning environment that replicates industry standards. From our multi-story distillation tower to our cold spray labs, Rowan chemical engineers graduate with hands-on experience. Rowan students have been able to work on projects sponsored by ExxonMobil, General Mills, Johnson Matthey, and the EPA, among a range of other agencies and companies. The college supports 4 major research centers: advanced manufacturing and materials, virtual and augmented reality, sustainable facilities, and transportation. Many institutions often reserve research center collaboration opportunities for graduate students, but at Rowan, undergraduates are welcome contributors to our thriving $50 million research operation. Our experiential engineering education department is home to the innovative engineering entrepreneurship degree and common first and second year engineering courses. The department leads the college's educational research program, ensuring Rowan students have the opportunity to directly benefit from groundbreaking discoveries. Rowan's nationally ranked mechanical engineering program is one of the most academically competitive departments in the state of New Jersey. Our graduates have recently pioneered advances in the aviation industry and in automated vehicle systems, among a broad range of other sectors. Along with students in ECE, select students might also be able to join an exclusive 4-year co-op program with Lockheed Martin. The college is also one of the largest tenants of the South Jersey Tech Park of Rowan University, located just 1 mile from the Glassboro campus. This center houses several research centers and labs and offers opportunities for private sector businesses, small startup companies, and university faculty and students to collaborate and innovate. The diverse range of student-run extracurricular activities also affords students with opportunities to apply what they've learned in the classroom, form relationship with their peers and students from across the college and university, all while tackling exciting challenges and service opportunities. This is the Henry M. Rowan College of Engineering at Rowan University.
So what kind of jobs are available for electrical and computer engineers when you graduate? What's the typical salary, an entry-level salary for graduating ECEs? How do I know which program is the right one for me? What kind of experience will I have in the program? What curricular and extracurricular activities are there? I'm still trying to figure out which field of engineering that I'm interested in. What exactly do ECEs do? Hello and welcome to our virtual open house. My name is Robbie Polikar. I'm the department head for electrical and computer engineering. And today I'm going to try to answer some of these questions and hopefully help you decide perhaps one of the most important decisions that you'll be making in your life. We use our tagline, "Future is what we do," and that's just not a tagline. That is, in fact, there's quite a bit of truth to that statement. And I'd like to tell you a little bit about why that is the case. When we talk about electrical and computer engineering, these are some of the areas that are most traditionally associated with electrical and computer engineering. When people hear about this, they say, yeah, that's electrical computer engineering. Power generation, transmission, and distribution of that. Obviously, everything we use, every device that you plug in or that you have a battery needs to use power. Computer design and architecture, control systems, electronics, microelectronics, telecommunications and signal processing. This very medium that we're using to communicate with you and much of the remote learning and work that's being done nowadays is done through signal processing and telecommunication. Embedded systems, smart devices, Internet of Things, those smartphones, smart cars, smart lighting systems, all of these are part of electrical and computer engineering. Now, what most people don't realize, however, that is really I would say, relatively small part of electrical and computer engineering. Electrical and computer engineering is perhaps by far, and I mean by far, the most diverse and the furthest reaching of all engineering fields. Why? Because electrical and computer engineers have their fingers in just about all of these, and this is a really small list. I do start with automotive and electric vehicles. When we usually do open houses in person, I ask incoming prospective students, which field of engineering do you associate automotive typically, or even robotics? And the typical answer I get is mechanical engineering. And that's true. There is a lot of mechanical engineering involved in those areas. But did you know that if you were to buy a new car today, 80 to 90% of that, the value of that car is attributed to electrical and computer engineering. And that's for conventional cars. If you're talking about electric vehicles, then that value goes up to 90%. Robotics. Much of the sensors and the decisions that are employed within robotics are product of electrical and computer engineering. And the list goes on and on. Unmanned autonomous vehicles, drones, obviously we're using them increasingly more often. Brain-computer interface, nanotechnology. Another phrase that you're probably hearing very often nowadays, machine learning and artificial intelligence. That's a field that marries electrical and computer engineering and computer science. Perhaps I would even argue that much of the life-saving devices that we use in medical industry are in fact built, designed, implemented by electrical and computer engineers. Biometrics, bioinformatics, genetic engineering are further examples. Aerospace, aeronautics, defense industries, smart grid, alternative energy, renewable energy systems. RFIDs, those are the radio frequency ID tags. The easy pass systems that you use in your transponders, as well as the asset management systems that department stores use. Forensics, cybersecurity, and all of these are areas that are made largely possible today through electrical and computer engineers. So in a field that is as broad and as further reach as electrical and computer engineering, how do you prepare a future engineer in 4 years? And so that requires strategic planning. And then we set out to design this program about 20 years ago. We asked that question to ourselves: how do we train the 21st century electrical and computer engineering who can be successful in any one of these areas? And the first thing we decided was that this is going to be a combined electrical and computer engineering program. And I want to emphasize that because this is somewhat unique. There are about 600 or so, 596 to be exact, electrical and computer engineering departments in the United States. The vast majority of these offer an electrical engineering program, a computer engineering program, or a combined degree program in both of those areas. And those combined degree programs typically done through different tracks. A combined electrical and computer engineering degree program that is accredited as such is relatively rare. So this is one of those programs. Of course, in such a program, we have topics in both core areas of electrical engineering and computer engineering, electives in emerging fields, quite a bit of a research and entrepreneurship experience. And I'm going to talk a little bit about specifically the engineering clinics and the clinic consultant. Those are the hallmarks of our program. I do want to mention that all of the courses that we offer in the ECE major are lab courses. They're truly hands-on, minds-on courses. And I'll also mention an optional 9-month co-op program that allows you to graduate in 4 years. Now, my colleagues and even sometimes my students kind of make fun of me because of the overly colorful nature of this ECE curriculum flowchart. But the different colors represent different aspects of the program to allow this program to help train diverse engineers. Obviously, there is our math sequence. There are courses that you would expect in any electrical engineering program, such as circuits, electronics, perhaps electromagnetics. There are courses in signals and systems, digital signal processing, telecommunications. Certainly for our computer engineering part of the curriculum, there's digital systems, computer architecture, embedded systems. Some of these courses we will certainly find in just about any electrical and or computer engineering program. What you're not going to be able to find in most of these programs, however, is the clinic sequence. At the top is our clinic sequence. That is an 8-semester sequence starting from the first year, going all the way through to senior. And these are project-based design courses. And we're going to talk about that in more detail in just a moment. I also want to mention the clinic consultant. That is unique to the electrical and computer engineering program, in the sense that we train our students to be successful consultants when they graduate as well. A large number of electrical and computer engineers do consulting work either as a side job or in some cases as their main career. And in that series of courses, we teach you how to find customers, how to manage customer expectations, how to build customers, how to deal with ethical issues when they do arise, and they do arise. So those unique entrepreneurship courses are our clinic consultant. The clinic sequence, however, is of course the hallmark of the Rowan engineering programs. So I'm going to tell you a little bit more about our clinics. So the clinics are industry and government-supported real-world research and development projects. Now, the phrase real-world project gets thrown around a lot. Every program will tell you that their students work on real-world projects, and of course they do. You cannot have a non-real-world project. What sets the clinics apart is that they are unsolved real-world projects. So whenever we look at what projects to use in our clinic sequence, we want to make sure that these are unsolved real-world, real challenge problems. And not only they are real world, so-called, they do actually have real expectations, real deliverables, real milestones, real consequences when those deliverables are not met. The clinics serve multiple other purposes. One of them is they are vertically integrated with the graduate program. A number of our students, when they graduate with their bachelor degree, they continue for a graduate program, and in that graduate program, their clinics can serve as their thesis work. This is an exceptional opportunity, not just for students, but also for our industrial partners, because many of them hire the students who work in these clinic projects, in part because they don't have to train them at the time that they're hired. Those students come prepared, ready on day one to be successful in the work that they're doing. So where do these clinic projects come from? Much of them come from our industrial partners. They would come to us and say, we have such and such problem. We either don't know how to solve this, or we know how to solve this, but it will be too expensive for us. Can you solve this, or can you do this in a more cost-effective way? And if we have the expertise in our department in that area, we take that project, we properly scope it. Sometimes if it's a large scope project, we may divide it into multiple clinic projects, and different teams work on it. And the clinic projects may last anywhere from as short as 1 semester to as long as multiple years, where students go in and out of those projects. Another group of projects come from federal government, the research funding agencies such as the National Science Foundation, National Institute of Health, Department of Transportation, Department of Energy, NASA. We have quite a few projects from NASA as well. And we do also have some student-initiated projects as well, and I'll talk a little bit about that in a moment as well. The clinic projects for us also serve the purpose of capstone design. The accrediting agency for all engineering programs in the United States is ABET, Accreditation Board for Engineering and Technology, and they require that every engineering program has a capstone design or senior design project. And in most schools, this would be a class called senior design or capstone design. Of course, by the very nature of that name, it is typically reserved only for senior years, whereas here we spread this across multiple years. The other question that I usually get is, well, how many such projects are there that I can choose from? The number of senior design or capstone design projects offered by any program varies by the size of the program. Small programs would usually offer you 5 to 10 such projects to choose from. Mid-sized programs, mid-sized like us, would usually offer about 10 to 20. And large programs that have thousands of students usually have 40, 50, 60 projects to choose from. We're unique in the sense that we are able to offer a lot more than that. When I do this presentation in person to prospective students, and I ask them how many things we offer, and they see this screen in the back, and it says 24. And that's my little trick because the number of projects that we offer in any given semester is actually substantially higher than that. Because of the fact that this is a college-wide effort, we are able to offer about 160 plus projects in a given semester. Let me pause for dramatic effect. 160 plus projects every semester. And these projects cover a very wide scope of topics. Within just the ECE, we have projects on machine learning. We mentioned some of them here, deep learning for lung cancer. There is machine learning for genetic analysis. We have projects that are related to virtual reality, which I'm going to talk a little bit in a moment. There are aerospace and NASA-funded projects, such as the NASA Wireless CubeSat, as well as the NASA competition. We have projects on cybersecurity. We have projects on power systems. The list goes on and on and on. Now, obviously, I don't really have the time to talk about all of those, but I do want to highlight a few of them just to give you the idea that these are truly unsolved problems. One of the several projects that we have come from our virtual reality center, the only kind of its type in the state of New Jersey that allows us to do a variety of medical as well as non-medical type research. One of our proudest moments came when we were supported by NASA for a CUBE satellite project. And so we were tasked with building a CUBE satellite. These are satellites that are about 4 inch by 4 inch by 4 inch, about 10 centimeter cube. And it is a fully working, full-fledged satellite. Our students work on this over a course of 3 years. They built the satellite. The satellite was sent to NASA, which shipped the satellite to the International Space Station. This picture actually shows about a second after I don't know if you can see this in these videos, that the satellite was deployed from the International Space Station. So this became a great moment of pride for our students and made some lighthearted jokes with their peers. Yeah, we have a satellite that's orbiting the Earth that we designed. What did you do last weekend? Other projects include student-initiated projects, such as building an electric vehicle, as well as building robotic hands, prosthetic hands. And I'd like to introduce some of our students to you to talk a little bit about this. So to talk about the prosthetic robotic arm, here is Richard and Haley.
Hello, I am Richard Steltz. I'm a senior in the ECE department.
And I'm Haley Schuster, and I'm a junior in the ECE department.
We've been tasked with doing the robotic arm this semester. We were trying to build a robotic prosthetic that is both affordable, practical, and realistically can be used by someone who's amputated and might need another arm. We're trying to do this by reading in neural signals from the arm using a small armband and using artificial intelligence and machine learning to read our signals and portray it accordingly. I've personally been working on this clinic for over a year and a half now.
And I just started working on this clinic project at the start of this semester. So what's interesting about our robotic arm is that it's controlled by neural signals that are collected on the surface of the arm using a small armband as intended by the user.
Some of the signals can be shown over here on this monitor. As you can see when I'm opening and closing my hands, that the signals are coming up and that they're displaying different motions based on what I'm doing. From this, the machine learning is able to notice these little changes and will act accordingly. The sensors on the armband are detecting all the little changes in my nerves and what the electrical changes that are happening in my arm. It sounds like a lot, but it's pretty interesting, and it manages to make a complicated problem a lot easier for the users themselves. We have all these all these servos, little motors and stuff that are controlling this hand that we've been designing for a couple years now. We've had a couple different models over the years that have been slowly developing to make it better. Each clinic period, each semester, we make a new model that updates and is more realistic to a real human hand. The original ones were functional, but they didn't look very great, and for a prosthetic, that's something that you care about. You can see the effects of it in the model here. I'll start off the hand, and then we'll start by opening the hand up. As I go to close my fist, it'll mimic the motion. If I open it back up, it'll do the same. I'm able to point at things if I really want to. General motions are pretty substantial for someone who's missing their arm. So this gives them the ability to, just by wearing an armband, have an arm again or some dexterous motion to them. All right, and we can cut that off.
So this arm functions a lot better than the previous models, but we're still looking to make it more practical and something that people can use in their everyday lives. And we also want this to be dexterous enough to allow fine motor controls such as typing.
All right, and then Dr. Polakar, back to you.
All right. Thank you, Richard. Thank you, Haley. I appreciate your involvement in this. I would be remiss if I didn't mention a little bit about our labs and facilities. One of the biggest pain points for me today in doing this presentation is the fact that we cannot have you here in our building looking at our facilities and laboratories in person, because you would be very impressed. We spend quite a bit of our budget and resources every year to update our labs. And I'm proud to say that we probably have one of the best equipped undergraduate teaching labs that you'll find anywhere. I do want to mention that not only we provide these modern equipment to you, but what we also do so in a setting that allows you to learn in the best pedagogical environment as possible. Just about all of our classes are taught in what we call teaching labs, and you see the pictures of these teaching labs and the general setup, and I'll put up videos for these so that you can see them more up close and personal. I'm going to give you the how to find those at the end of this presentation. But these are teaching labs that have 12 stations in them. Each station accommodates up to 2 students. So a typical class size for us is 24. Even though when we may have about 100 students in any given class, we never run that many classes with that many students. In fact, we designed our new facility just so that not only us, but the future generation of administrators or the faculty cannot be tempted to have large class sizes. So all of our classes have a maximum class size of 24, and they are done in a lecture lab combined fashion. So this allows the students and to try something, to test something at any point in time during the lecture, saying, oh, well, this is what the professor has taught. Well, let's see if this is in fact true, or let's see how this works. And you have the ability to do it right there, right then, through these small class size combined lab lecture setup. Now, I do want to mention a little bit about our unique partnership with area employers, and one of them that I want to highlight is Lockheed Martin. Lockheed Martin hires a large number of our students in any given year, and we have a unique co-op program with them. And that co-op program is optional. This is only for students who are interested in this. Is structured in such a way that it allows you to complete your ECE major degree program and requirements in 4 years. And the co-op program is anywhere from 6 to 9 months, but we have creatively restructured our curriculum so that you are able to take some classes while you're there. We move certain classes around so that you can complete the 9-month co-op as well as the degree requirements in 4 years. Now, some of the questions that we receive often is, okay, well, that's great curriculum, but what else can I do? We have a pretty active bunch of students who do a lot of extracurricular activities. We have a Robotics and Automation Society. We have students who are involved with the American Institute of Aeronautics and Astronautics. We have Women in Engineering, whose one of their major events is the wearable electronics competition. But perhaps the largest of these is the Rowan IEEE student branch. IEEE is the Institute of Electrical and Electronics Engineers. Just about most electrical engineering programs will have a student branch for them. And our IEEE student branch is a particularly active bunch, and it is the largest student club on campus. And to tell you a little bit more about this is Hughes Bryan, our current chair of the IEEE Rowan student branch.
Thank you, Dr. Polikar. Hello, prospective students. My name is Brian Costantino. I am currently a junior in the ECE department here at Rowan, and I am the current president for the Institute of Electrical and Electronics Engineers. So IEEE likes to focus on 3 aspects of student advancement. There's the professional development, the networking skills, and the technical skills. So on one hand, we offer numerous workshops to cover those technical skills that you'll see throughout the ECE curriculum in a multitude of classes, as well as hosting presentations by guest speakers from highly reputable companies such as Google or Lockheed Martin. Additionally to our technical workshops, we hold a tutoring program so that students can meet upperclassmen and no one feels left behind, and you can gain these skills if you're feeling behind in a class, and everyone has the opportunity to succeed. So IEEE also hosts numerous social events such as paintball, ski trips, video game tournaments, Topgolf, and much more. So you can send the camera down. So what you're seeing right now is a demo of our sumo robotics competition, where students compete to build the fastest, smartest, and strongest robots that they can to try to push each other out of this little doyo here, I think it's called. So here, I'll give it a little demo. Oh, there we go. Yeah. All right, so this is a great event to get students started with seeing a lot of the the skills that you're going to need throughout the engineering program here at Rowan. You use C programming to control the robot's behavior, and you will use soldering to actually build the body. And we hold 2 of these events: the Scratch tournament and the Kit tournament. Depending on your level of expertise within the field. The Kit tournament will give you a robot, and then you basically just build it. And the Scratch tournament, you can build a robot from scratch and have that compete. So this is one of our biggest events by far. Students will compete for a couple $100 worth of cash prizes, free merch, free food. It's a fun social event. You get to meet people, a great time. So now I'm going to jump over to ProfAX. ProfAX is one of the biggest events that actually is held here at Rowan. Over 200 students, all different ages, all different experience levels, come out to build projects. code and hack and create projects to help humanity. So it's a great learning and social opportunity for anybody who is interested in getting involved in engineering. I would definitely recommend, all the prospective students. My senior year in high school, I went out to ProfX. I had a great time, and I never even touched the engineering field before that. It got me really acclimated to a lot of these subjects that you'll see throughout your education. And it helped me meet a lot of people, a lot of people that I ended up growing close with throughout my time here at Rowan. So, with that being said, the ProfX this year, 2021, or I guess next year, is going to be happening on Saturday, March 6th. And you guys can sign up and find more information at profhacks.com. So, that all being said, that's going to wrap up my presentation about the student branch. I hope I've been able to explain what makes IEEE such a worthwhile and unforgettable experience to students here at Rowan, and what makes the EC department here at Rowan such a great opportunity for any student. So thank you, Dr. Polakar. You can take it away.
Thank you, Brian. I appreciate it. Really is a great opportunity. So I encourage all of our students to participate in IEEE activities. And IEEE, Brian has been a bit modest here. IEEE is such a successful group that we actually drove students from other disciplines into our IEEE student branch as well. We have a number of students from mechanical engineering, other engineering, and as well as non-engineering disciplines on campus who are part of this exciting group. Now, the other question that I often get is, well, okay, so what kind of jobs can I expect, where can I expect to work when I graduate? So I started preparing this slide over the years, and it's getting increasingly more crowded. But this is just a subset. These are the names that I thought you would recognize where we sent many of our students. We have students working at Google, at Amazon, at L3Harris, or formerly known as L3 Communication, Disney, Boeing, Lockheed, of course, Intel. We even have our graduates who became professors at various well-known universities, including University of Arizona. A lot of our students go to FAA Tech Center, which is in Atlantic City. Of course, local power companies is another area. But I also encourage our students to go pursue graduate education opportunities. Many of our students will simply continue their work here at Rowan into our master's and PhD programs, but many others would seek PhD opportunities elsewhere. And we've sent students to some of the best-known schools that you've heard their names: MIT, Harvard, Georgia Tech, Johns Hopkins, Carnegie Mellon. We had several students at Columbia, at Stanford, University of Illinois, Rensselaer, Princeton, and so on and so forth. But not all of our students work or go to graduate school. In part, perhaps because of the clinic as well as the clinic consultant, we highlight the importance of entrepreneurship. And many of our students and graduates seek opportunities in entrepreneurship, in establishing companies and businesses of their own, and many of them have been extremely successful. Perhaps the one that I want to mention today is a company called Verge Aero, established by Tony Samaritano and Tony Merlino. These gentlemen, and Chris Franza, I must add his name as well, they worked on a drone. At the time that they were students here for their clinic project, they built a quadricopter from scratch. And this is about 8 years ago or so, at the time when drones or quadricopters were not household items. They built one of the first such personally built devices from scratch. Today they run a company that does drone shows. If you've seen the show that was done in Philadelphia several months back for the first responders, as well as most recently in Joe Biden's speech, if you saw that drone show, that was actually done by these guys. We're extremely proud of them. They're called Verge Aero, so I encourage you to look up their name, and you can see more of their shows there as well. So we pay quite a bit of importance to entrepreneurship as well, and now that we also have an entrepreneurship engineering program within the Rowan College of Engineering, we even expect to see more of these successful companies as we go along. All right. I would be remiss if I didn't mention some of our awards and recognitions. Perhaps the nationally most visible one of this is, of course, our recent rankings in US World News and Report. We ranked as number 16 among undergraduate electrical engineering programs. The College of Engineering is ranked number 17 as a college, and so we're very, very proud of them. But I have to say that is not what we are most proud of. That is not the recognition. That is not the award that we're most proud of. There are lots of schools that are not ranked, and they have excellent engineering education program. We're more proud about this particular award. This is given to us by an organization called ECEDA. ECEDA stands for Electrical and Computer Engineering Department Heads Associations, and they awarded us the Innovative Program of the Year award a couple of years ago. And the reason we're so proud about this is because this is an organization that consists of all of the electrical and computer engineering departments in the United States. They are our peers. These are all the other electrical and computer engineering programs that decided that this is a truly unique, truly innovative program, and we're very for their recognition. But perhaps the one that matters to you more is, of course, the accreditation. As I mentioned earlier, all engineering programs in the United States are accredited by an organization called ABET, Accreditation Board for Engineering and Technology. And ABET visits programs either every 2 years or every 6 years, depending on how successful they have been in their accreditation visit. I'm happy to report that in every ABET visit that we have had so far, we have received a full 6-year accreditation. And I do want to also mention some of the comments that we received from ABET. When they accredited our program, they indicated a number of program strengths, such as the strong commitment to curricular innovation, allowing students to understand the breadth and depth of various different specific areas, different credentials, different certificate programs that we have, the unique co-op program, as well as our ability to prepare graduates for unique job opportunities. And so that is important to you. Now I want to start wrapping up with a particular question that's haunted me when I was a student, and I think I'm not the only one. Many students struggle with the following question. When you're choosing a program, you tend to pick one of two general options. There are large universities. Typically, these are research universities. Because of their size, they have resources and facilities to match their size. But because of their size, they also have somewhat less of an individual attention to students. You are in classes with 300 other students. You are perhaps just a number. On the other end of the spectrum, there are smaller liberal arts colleges that, because they are small, they're able to provide you with an individual attention. They don't perhaps have the facilities and the resources that match those larger universities, but what they do offer instead is this very strong emphasis on undergraduate education and very individualized attention. So which one do you pick? Where do you go? When we established this program, we wanted to answer this question, and we kind of realized that this is a false question. This is a false dichotomy. This is not a decision that you have to choose one or the other. And this is why we decided to create a program that has a very strong emphasis on undergraduate education. That is our core mission. And we do this in part through small class sizes. But we don't avoid the research aspect of it. That is how you become the engineer for the 21st century, for the future. So this is a research university, and research is very much valued and very much integrated into the undergraduate curriculum. And we do this, of course, you guessed it right, through the engineering clinics. In part of that, of course, we are a program very much focused on project-based learning, hands-on learning. Not only the clinics, but every one of our ECE major courses are lab courses. That's a direct result of that. And because of the small class sizes, we are able to provide quite a bit of individual attention. And we also have a unique advising process. We don't have just one advisor that kind of answers all of the students' questions. All the ECE faculty in our department act as advisors. And we do all of that at the cost of a public education. And Rowan's ECE program is probably the best value that you will find anywhere in the state of New Jersey due to our unique state public institution. Now, I'm going to wrap it up with some facts and figures and another set of questions that I receive quite often. Our admission criteria, the number of applications, the number of students we admit, the placement rates. Now, the average SAT for those students who take an SAT for the 2020 applicants, so those are the students who arrived in fall this semester, so that was 1324, and their average GPA, unweighted GPA, was 3.82. So you can gauge what kind of student background we're looking for. Now this year we are going SAT or ACT optional, so you're not required to submit such a standardized test scores. But if you're not, then we're going to ask you to write another essay. One of the things that I do is I evaluate personally each and every application that we receive. I read everything that is submitted, not just your transcript, but I read every essay that you write, every letters of recommendations, every information, and we try to find, we want to make sure that this is the right program for you. And if we admit you, we believe that you have what it takes to be successful in a challenging program like this. The number of applications we've received over the last couple of years have been about 350, and the number of incoming students this year was 100, and this has been a college record for this year. The faculty size, right now we have 16 full-time faculty, 8 part-time faculty, and the student-to-faculty ratio is about 19. The retention rate, so that is the percent of students who are still with us after a year, is about 87%. I want to mention that this is a relatively large, relatively high number, and that is true across the College of Engineering. But if you look at the national numbers, the national average is usually around upper 50% for engineering programs. So we're quite proud of our retention rate. But perhaps the number that you want to know, that you're most interested, are two numbers. One, what's the placement rate? What percent of our students are placed when they graduate from this program? And oh, come on, admit it, I know you want to know this. How much am I likely to make? So the placement rate for us has been about 95 to 100% every year, and that is typically at the time of graduation, not a year out or anything. Our students have been extremely in demand, and we're very proud of that as well. The average starting salary, so I gave you the series of numbers back in 2010, was $59K, and it rised over the years, and last year it was $72K. The highest salary that was given to a student last year was a student who worked in my clinic project in machine learning, got a job offer for $116K of starting salary, and he received this offer at the time that he was doing an internship between his junior and senior year, so it's a full year ahead of graduation. Okay, so with that, then I'm going to put up this information here. So again, this is my name and email address, so if you have any questions, feel free to contact me at any future time. We do have a web page, and the address is very easy to remember, rowan.edu /ECE. So now we're going to get to some of your questions.
What is the department's approach to supporting diversity and equity and fostering?
Okay, so we have questions about the department's approach in equity, diversity, and inclusion. So this is an important topic, and it is important enough that the university recently established a division that focuses on those issues. When we admit students, we want to make sure that the students we admit represents the demographics in our region, and I do have to admit that, and this is true for just about all electrical and computer engineering programs, our population of our women students is somewhat lower than other programs on campus, but it is growing. And we have specific reach out programs for a variety of different underrepresented groups. So. All right. I do have a couple other questions that I've received here. Let me quickly address those as well. Pathways to grad school and other credentials have been asked. As I mentioned, the clinic projects, the clinic program allow a natural transition to graduate programs for those students who are interested. We do offer a 5-year BSMS program as well as direct admission to PhD program after that. Another question that I receive is how do you do remote learning for labs? And excellent question. Through a variety of different ways. One of them is we have student-owned devices that they can run their experiments at home through those. Much of the equipment that I mentioned, I showed you, are networkable equipment, and therefore we are able to allow you to access these equipment from home to do your, and some of the other experiments are truly computer-based. Okay, now if you do have other questions, please feel free to reach us. One thing that I want to say before finishing up is to show you where you can find additional information. So this is our webpage, rowan.edu/ECE. And if you click to About ECE, you will see additional information, and perhaps the one that I want to focus on is the facilities, capabilities, and virtual tours. If you click on that, we provide a number of videos that focus on different aspects of our program, different labs, and different resources we have for you. So,
Dr. Polkar, we have one question that just came in.
Yes.
The question is, do engineering majors receive priority for engineering courses? Can non-engineering majors take engineering core courses? And then, do any graduate students take classes, or is it all faculty-led?
Okay, so a couple questions here. Do engineering students have priority over engineering courses? Not only do they have priority, they actually have sole access. Engineering at Rowan is a restricted major, meaning that non-engineering students cannot take engineering classes unless they have special approval from us, and every now and then we may do that, but that's rare. So yes, you do have priority registration. In fact, you have the registration access to our engineering courses. And the other question that was asked was, could you repeat that? What was the other one?
Do any graduate students teach classes, or are they all faculty?
Okay, so do any of our courses taught by graduate students? All of our courses are taught by our faculty. Now, we do have graduate students who assist faculty. Typically, that happens in the labs. Due to the unique nature of the lab, we often need additional assistance in the lab to do troubleshooting, to answer this question. So when we do use graduate students, we typically use them to assist faculty in the labs to answer student questions and do troubleshooting. We don't usually have graduate students teaching an entire class on their own. All of our courses are taught by our faculty. So, okay. With that, it looks like that's all the questions that we have. Again, if further questions, please reach out to me directly at polkar@rowan.edu, as well as through our webpage, and the information is provided. Much of the information that I provide today you can find in various parts of our webpage as well at rowan.edu/EC. Thank you, and please stay safe.